Hello, we're working on Chapter 6, Section 4. In this section, we are going to explore a little bit more with factoring, and we'll cover that in the example too. More factoring stuff. In this video, in this example, the video for this example, we're going to be talking about factor pairs and finding out if a binomial is a factor of a polynomial, and we'll talk about what that means. I'll give you an example here. All right. So I'm going to be doing example 1, trying to find out if a linear binomial, that means a binomial that has two terms, 1, 2, and the linear part means I just have x to the first power. So x to the second power means quadratic, x to the third power is cubic, x to the fourth power is quartic. So we're just talking about linear binomials, trying to find out if it is a factor. This video is one of the steps toward one of the major themes in algebra, which we will be getting to later in this chapter. So there's nothing too difficult about this, but just pay real close attention because it means a lot. Let's connect this with what we know about with numbers, with arithmetic already. So I put in here, what are the factor pairs of 18? Now, there's two things when we talk about factor, probably more, but there's two things that I'm thinking about. One thing is you can completely factor a number. That means that you're going to tell me all of the prime numbers that can be multiplied to equal that. So when I completely factor 18, I get 2 times 3 times 3. But when I say what are the factor pairs, I'm looking for the pairs of numbers that multiply. They don't have to be prime. So please be aware of that. I know some people have been asking me about that. What are the factor pairs for 18? Well, I have 1, where's my marker working? And 18. I have 2 and 9, and I have 3 and 6. And just for the purpose of this example, I'm going to switch markers real quick. Just for the purpose of this example, I'm going to leave out the negatives. Usually we don't assume negatives. It's just in my mind because in my intermediate algebra class right now, we're working on factoring polynomials. So if 18 was part of a quadratic trinomial we're trying to factor, then we also have to include the negatives sometimes. But just want to acknowledge that. Now, what happens if I take 18 and say, for example, if I say 18, see I use change of marker, divided by any of these numbers. So 18 divided by 2 equals 9. Those are the factor pairs. 18 divided by 6 equals 3, etc. You're okay with that. But this is going to be the idea that we're going to get into. And I'm going to explain it by showing you what it's not. What if I said 18 divided by 5? Now, looking at this, you say, well, 5 is not one of the factor pairs, or one of the numbers I have over here, my factor pairs. Unlike 18 divided by 2, or 18 divided by 6, or 18 divided by 3, or 18 divided by 9, or even 18 divided by 1 or 18. When I divide, I get the other factor pair. But it's what I don't get that's important. Over here, I get no remainder. Why is there no remainder? Because they are factor pairs. They are all the numbers that I can pair up and multiply to give that. So if I divide 18 by any of these, I'm going to get the other number that goes with it, and I'm not going to get a remainder. But if I do 18 divided by 5, I'm going to get 3 remainder 3. That's because 3 times 5 is 15. 4 times 5 is 20, so that's too many times. What's the most number of times you can multiply 5 and still be under 18? That's 3. How many are left over? 3. What if I did 18 divided by, let's say, 12? So that would be 1 with a remainder of 6. Now, we have not talked about remainders in algebra since the last section, obviously. But before that, we have not talked about remainders in math for a good long time. Probably most of the time, when I say what's 18 divided by 5, you would take the 18, and then move it to like put a decimal point in there, put the hidden zeros in the 10th, 100th, 1000th places, however many you need, and then you keep dividing. So like 18 divided by 5 is actually 3.6. But we're trying to get into the idea, excuse me, we're trying to get into the idea that we want to discuss that if you divide and it doesn't go in completely, then we end up with a remainder. How's that going to help here? So what I want to figure out is x subtract 3 a factor of x squared plus 2x subtract 3. How am I going to know to do that? I'm going to divide this by that, and if I get a remainder that's not 0, then I know it is not a factor. But if my remainder is 0, then I have a factor. And being able to use this skill, being able to like start off with this binomial and divide and see if it's a factor with no remainder, that's a very important skill leading toward the main idea of this section. I don't want to give it away. All right, so we're just going to use synthetic division here. So I'm going to have 1, 2, -3, and I'm going to put 3 here. Synthetic division goes pretty quick. 1, 3, 5, and 15, which gives me 12. This right here is my remainder. Since the remainder is not 0, x subtract 3, I'll put an arrow so it doesn't look like a minus sign, is not a factor. So then you get into the question of, well, how do I find out whether it is something that is a factor or not? Then we have to try other things. Maybe x plus 3 is a factor. Maybe x minus 1 or x subtract 2. Maybe this cannot even be factored. How you go about that, we have a way to get around it, but also something that ties into like a major idea. We're setting you up for pre-calculus, in case I haven't mentioned that enough. Now let's try this one. Is x plus 4 a factor of this one? So I'm going to try synthetic division again. 2, 8. Notice that I do not have an x squared, so I have to put a 0 in here for the missing term. 2 and 8. So that 2, that 8, I do not have 0x squared, so I can do plus 0x squared for the missing term. And then 2x and 8. I have x plus 4, so I'm going to put a -4 right here. We'll go fast. 2 plus 0 is 2. -4 times 2 is -8, and I get 0. -4 times 0 is 0. 0 plus 0 is 0. -4 times 0 is 0. 2 plus 0 is 2. And then -4 times 2 is -8. 8 plus -8 is 0, and that is my remainder. So the answer is yes. Since the remainder is 0, x plus 4 is a factor. Now that's all that we're being asked to do for this problem. But just so you know what the next step is, I couldn't do it with this one, but I can do it with this one. I just need a little bit more space. I'll move that up a little bit so you can see it. That means that right here I've got, and remember this is the constant, this is x, x squared, x cubed, which is x to the 4th divided by x. So I've got x to the 3rd power plus 2. Oh, sorry, 2x to the 3rd power plus 2 times x plus 4. That times that is going to equal this. And you can multiply, if you want to use FOIL, go ahead, that's fine. But this has allowed me, synthetic division with no remainder, has allowed me to factor this. The next thing I would do is I would see if I could keep factoring this 2x cubed plus 2. And maybe we'll find other ways of doing that also. All right? The truth is that, spoiler alert, in the third video, we're going to find out how to factor that. All right? Let me do a couple more. I know in these videos, the first videos, as I introduce stuff, I kind of talk a little long, so I'll try to pick it up a little bit. Okay, so I've got x plus 2. That means I'm going to be using negative 2. 4 negative, oh, I should check. X squared, x to the first power. Yep, it's in standard form and it is in order. So I have 4, negative 2, 5. Putting my 0 down, starting to get ahead of myself. Negative 2 times 4 is negative 8. Negative 2 plus negative 8 is positive 10. And, sorry, negative 10. I catch myself. The only thing is that now it's being recorded. And negative 2 times negative 10 is going to be positive 20, which gives me a remainder of 25. So no, x plus 2 is not a factor of 4x squared minus 2x plus 5. So we'd have to try something else. All right, with this last problem, I have to go into something we were talking about in the last section. In the last section, I talked about long division. For the 3 problems we've done so far, they've all been synthetic division. For the last problem, we talked about long division and why we have to use long division sometimes. And what I framed it by was that if the binomial I'm dividing by has just x, in other words, oops, sorry, you can't even see that. In other words, the coefficient is the hidden 1, which, and we always said this, like, the book uses x subtract a, I talked about x subtract h, it doesn't matter. But either way, if it's just x plus or minus something, then you can use synthetic division. And I said that if you have a coefficient in front of the x being multiplied by the x, then you cannot use synthetic division. But then when I said that, I kind of had to say, except you're going to learn how to get around that in pre-calculus. It's not something that we cover here. So can I use synthetic division here because I've got the 3? Well, no. At least not until pre-calculus. But, so what we would do, before I go into that part, so what we do is we could use long division for this, okay? But here's the thing, and this is not always going to work. This one's kind of tricky. You see this right here, the 3x minus 6? Well, this itself can be factored. So I can factor that into 3 times x minus 6. And also, I have a common factor of 3 here, 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 and here. This is 3 times x to the 4th minus 2x cubed plus 2x squared plus 1x subtract 10. So what I'm asking is, can I multiply this right here by something and get this? Well, the 3 is there, the 3 is already here. So I can ignore the 3. Now that's not always going to happen, okay? I just wanted to talk about it with this one. If I cannot factor out a 3 here, then that 3 is not going to matter, okay? Or, I got to be careful, if I cannot factor out a 3 or a multiple of 3, which of course would have factors of 3. So if I factored out like 9 from everything, that would still work. But the 3's are going to be taken care of, right? So what I really have is x minus 6 a factor of what's left. That 3 is already here. But is the x minus 6 going to be a factor of what I have left? All right, so synthetic division. I'll use my 6 here, and I got 1, negative 2, 2, 1, negative 10. Go quick. 1, 6, 4, 24, 26. Yikes. 6 times 20 is 120. 6 times 6 is... did I forget something? Did I do a sign correctly or incorrectly? I got plus x, so I got 1, negative 2, 2. I've got everything in order. This one's just kind of blowing up. I thought this one would work out. That's okay. All right, we'll work it out. All right. So 1, negative 2, positive 2, positive 1, negative 10. Yeah, I didn't write anything wrong. Put my 0 here. Yeah. I caught it. Oh my goodness, my goodness. I'm leaving this in the video so you can see my mistake. I didn't factor correctly. This is 3 times x subtract 2. All right, so, oops. That's okay, I got plenty of space. So it's actually 2, 1, negative 2, 2, 1, negative 10. And guys, seriously, I could start this video over again. I just got to print 2 sheets of paper. I'm leaving it in because I need you to see that real people who actually are good at this still make mistakes. So don't beat yourself up or anything. All right, let's go a little quicker. 1, 2, 0, 0, 2, 4, 5, positive 10, 0, no remainder. So yes, 3x subtract 6, going back to the original, is a factor of the original. All right, I'm going to leave that in so you can see. Plus, I don't even know if I could edit it anyway. Now I want to do the video again. All right, I'll see you in the next video.